Hello class, we're looking at example 7 from page 408 of your textbook. Our first example dealing with a logarithmic function and its transformations. Okay, so for the function f of x is equal to log base 10 of x subtract 2 plus 1. First question is, describe the transformations necessary to transform g of x, which is log base 10 of x, on f. So we're moving this function onto this function. Now notice they're both base 10. That's the reason we can compare them with each other. Okay, so in order to do that, we're going to have this is in the C position, like we talked about in the last video, C, and this is in the D position, like we talked about last video as well. Okay, so we have a horizontal translation, or horizontal shift if you prefer that phrase, and it is going to the right, okay, because remember this negative sign is part of our transformational form, so C is actually positive 2. Horizontal translation 2 units right, or to the right. Okay, and we also have a vertical translation. This guy here, this plus sign is part of the transformational form. So D looks like what it actually is. So that's a vertical translation or vertical shift, 1 unit up. Okay, so that's the transformations. That's the only thing that's changed between the two. B, write down the equation of the asymptote of f. Okay, so asymptote of g, let's talk about it first. Okay, it's a base function, it's base 10. The asymptote is going to be asymptote of g of x equals log base 10 of x is x equals 0. Okay, so if we then think about that asymptote, so say that's x equals 0, this is it, the y-axis down here. We need to move this whole function 2 units to the right, 1, 2. So therefore that's going to change that asymptote. It's going to move it also 2 units to the right. So the asymptote of f of x is going to be x equals 2. Okay, so let's put that on here. I'm going to draw that on here. And this is, I'll label it down here, x equals 2 is our asymptote of f of x. All right, C, find the domain and range of f. Okay, so domain and range, the domain of this is going to be only from 2 onwards. Okay, so domain will be from 2 to infinity. Or if you like the other notation, x is greater than 2. The range is a logarithmic function. It's going to be from negative infinity to infinity, or if you like the other notation, y is an element of R. Okay. So of the base function, the domain here would have been 0 to infinity. We had to move everything to the right 2 units, so it became 2 to infinity. The range here would have been negative infinity to infinity. As we move everything over and up, it's still going to be infinity to infinity, negative infinity to infinity. Okay. All right, sketch the graph y equals f of x. So sketch this guy and the line y equals x on the same graph. Okay, so let's put y equals x on here. It's going to be this dot, this line, diagonal line. Okay, I've put my asymptote on there. As you can see, my scale is, each block is 2 units. But again, this is just a sketch, so you don't have to refer to the grid marks at all. Sketches are not as accurate as graphs. So this is a sketch. This was our command term here, sketch. So we know that this guy would have an x-intercept of 1, 0, but we need to move 2 units to the right and 1 unit up. So 1, 0 would have been here, 2 units to the right and 1 unit up would bring that point up to here. Okay, so that just sort of gives us an idea of where we're sketching that graph. Okay, so this is f of x. All right, hence on the same axis, sketch the inverse of that function. So the inverse of this log function is going to be an exponential function. We talked about that in the last video. So what is x becomes y, what is y becomes x. So we will have on our new graph, instead of a vertical asymptote of x equals 2, we'll have a horizontal asymptote of y equals 2 for this graph. And this point here can be reflected up to here. We can roughly think about where this x-intercept is. We didn't have to calculate it, but x-intercept will now become the y-intercept above here. And this is the asymptote. Okay, so thinking about this being reflected here and there. If you want to see another way for this to be drawn, it's in your textbook on page 408.